Hi. I think we iOS developers are not testing enough our code. And that's why I started a series about test-driven development in iOS. In this series, we will develop a small application that fetches data from an API and shows the data on screen. The API is an open API where you can fetch free books everyone can download and read. And we already started in the last video and created a project, added the test target and wrote our first tests. In this video, we want to try to mock a fetch from the API that we know in our test that our API client does actually get this data from the API. You might remember that we already had two tests. The first test looked for the first book in the fetch and the second test for the last book in the fetch. But this is not really what we want. What we want in a test is that we can set up what we are expecting to fetch in the test itself. So let's say I would like to have something like mock or a URL session or a session mock session. And I expect that to be URL session. And there I want to say, okay, the data I expect there to be is something like, let's say, I don't know what will a book look like? Let's have a look. The book will just have a title. Okay, so let's say we have something like an array in JSON, and in this array we have a title, and this title is this what we expect to have in this book. So this would be right now the JSON of a book we can fetch from the API. The API has lots more of information, but first of all we want to be sure that we can see the title when we fetch a book. And we want to make this a data object, and we use the UTF-8. So this is what we want to have. We want to set up everything we need in the test and see what we expect and then assert that we got what we expect. We can't do that for now because URL session mock isn't a thing at the moment. So we need to add something. We need to add it. We need to add code that we are able to mock an URL session. And we start with a protocol. And we call it URL session protocol. And in this protocol, we write down the API, the method we want to mock. And to find out what we can write there, we search first of all for URL session and see which API we find there. Oh boy, it's indexing. Okay, this takes too long. I don't want to wait. But what we can do here, we can say that we have an extension on URL session, and then we can use Control Command J to jump to the definition. And in the definition, we can search for the API we want to replace. We want to have the async. Oh, wait a minute. We are in the URL session. Oh, now it's found it. Okay, so we can now search for the URL session in the documents, the documentation, and there we see, for example, different kinds of APIs. But what we want to do, we want to provide an URL and get back some data, and we can do that with, for example, like this or this, where we get the data object and async rows, something like that. Or maybe with this one. I think this is, no, this is this one. This is the most general one, and we can use that to replace what we want to use in our mock. So we write this protocol, and it's called URL session protocol, and we tell it that we want to have, wait a minute, go back to this one, and we just copy it. And in the protocol, we can't make this property. We can't provide the default property. So this is the API we want to replace. And now we tell our code that URL session already conforms to the protocol, because it does. We just copied this code from the documentation. Okay, now we can use a session here and wait a minute, we use a lazy var session, and this should be a URL session protocol type, and if we don't provide anything until it is used, then we use here URL session shared. And now we use this URL session to fetch the books. So we say session. We fetch the books from an URL. We don't know yet. It's not important. We can just write URL string scope tips. Something like that. Not important at the moment, and we don't want to use a delegate. And what this does is, wait a minute, what is Xcode telling us? Immutable value service immutable. Okay, so we don't want to have a struct here. It would be too many things to think about, to keep in mind, and it's totally fine if you use the same API client all the time. In fact, it might be even necessary to use the same API client, because maybe we want to check if there is a fetch already running. So it's good to make it a class and not an API, a struct. And what is the compiler telling us? Yeah, we return a book. So no, we return something from here. So this is some data and some response. We don't need the response for now, just we make it an empty value, just a placeholder. And now, what is it telling us? Yeah, sure. We have to use try wait. And now we can try to to make books out of this with a JSON decoder, and we decode the data we get, and we expect it to be an array of books. Self data. So this requires that book is codable. So we go to book and make it codable. So now when we provide a session, a mock session, and oh, this can throw, sure, try and return. So wait for the compiler is happy. So this makes sure that when we fetch some data from this API, or when we provide this data in our test, that this data, or this can be, we can put our mock data into our test by using the API client, and now we set the API client session to the session mock. But we still don't have a session mock, so let's try to build this. URL session mock. Protocol mock. It's not actually a real mock, but it's often used. The type mock is often used, even though it's not a mock. This is more like a double, test double, but more like a stub, if you want. But I use mock most of the time as a name, because then the code for me is easier to read. But yeah, it's not really a mock. So we want to have a class URL session protocol mock, and this should inherit from URL session protocol. But we first need to testable import our main target, free books, because there we defined this protocol. And now we need to provide the implementation. And there's a trick. You can just Control Option Command F, and oh, and nothing works. Okay, usually it should fix all the problems, but for stubs somehow it doesn't work. So we can just type here or click the fix button, and now we have to provide this data. And as you already have seen in this implementation, I started here, no, in this in this test, I already used an initializer where I can provide the data I want to return. So we will do this here as well. I provide the data here, so at data, this is the data we want to return. Then we need an initializer in it, data self data is equal to data. So there we can control what is returned, and there we will now return the data and an URL response. And we create this URL response also here with that response, and we make it an HTTP URL response with the URL we get. Status code for now. We will later feed in the status code as well in the initializer, but for now we just return all the time that everything worked, and it's the HTTP version. Well, I don't care for now, so I'll just provide it with a nil, and this is also nil. So let's just make this code easier to read, like this. And now we can return this data and the response. Wait. Okay, so this is yeah. So this can fail. For now, we just force unwrap it, and or let's make this clear that we know what we are doing by let and else fatal error. So this does essentially the same as the exclamation mark, but here I tell myself I know what I'm doing. I know this will crash if it doesn't work, and this is for me, for my future self, easier to understand that I just knew what I was doing there. Okay, so now we have this URL session mock, but it's called differently. It's URL session protocol mock. So we used it here. And now the data, what is this? Why can't we? Oh yeah, sure. So the data can fail. Okay, so we try to for now we force it here to make the compiler happy. Okay, the compiler is happy, but this is not what we want to do. We want to use again this unwrap to make it clear that, or to make the test fail if it doesn't work. So let's do the data we want to return. Also use try xct unwrap. It should always work because we are not doing some strange things here in this data object, but still it's nice to have this, the help from the compiler if something doesn't work as expected. So the data is now not optional anymore, and this should make our test compilable. And when we now run this test here, it succeeds. Let's just see that it can fail by removing the O in Romeo. And we run it again. And it still, no, the build succeeds. Yeah, so this is a great test that we actually provide this data to the test and can now test that this data actually went into the book object. So this is a good thing that we can now prove that this data is used when we fetch from this API. So we can now use the same thing down here in our second test, but this is a different book title. It's way longer, but still you can use it here, and we have to remove this one. So let's make that easier to read. No, wait. Next. So now this is easier to read, and now this test should also pass. Great. So this means we can now use this data we provide here in the test above, and we can provide our API client with data to be returned from URL session. So when the API client calls the URL session, we now provide in the test what comes back from that session. So we have full control over the API, and it doesn't call to the real web server or to the real web or to a real website, and therefore it's very fast. And this is something you want to have in the UI in your unit tests. They should be very fast, and this is what we have done here. So let's see. we now have this. We would like to clean up this code a bit because it's not easy to read what's going on here. So I would like to have, I would like to create a book project, a book in this test, and let this URL session protocol mock automatically create the return from this book array, because we are getting an array from this API client. So let's do that here. I create an extension, URL session protocol mock, and this is init with books book. And now we get try JSON encoder. It should encode our books. They are encodable. We made sure that this works, and we also tried. We have to do that in a do catch block, and this should throw an error. Do we already have some logging here? I'm not sure. No, we don't have some logging here. Okay, encode is unused. Yes. So self data equals 2. And if this doesn't work, yeah, that's just fail for now, because if it doesn't work, we want to be notified by the test that we did something completely wrong. In real code, you wouldn't do that. In real code, you would provide a fallback, a fallback if it makes sense. But in a test, it's okay to crash, because the test should tell us as fast as possible when we did something wrong. Okay, so doesn't it? Did you mean to be inconvenienced? Yes. Let property data may not be initialized. Use self init or self. Okay, I see. So now we have the data, and now we can use here self init with data. And what we also need to do is this could fail, so we need to provide with the code that tells the compiler that we know that this initializer can fail. Okay, with this implemented, we can create a book. Book equals to book, and we provide the title. The title is Romeo and Juliet. And now we create this session mock with this book. Books, book, something like that. Easier to read, even easier to read. So, but this can fail. So we again need an try xct unwrap. So to remind you, that try xct unwrap provides us with this value if it's not optional, if it's not nil, and if it is nil, then this test fails in this line. So this is a good method to unwrap something in a test and fail the test if you can't unwrap it. Okay, so let's do the same here. We book equals to book. Sorry for that. Book title, and this is the title of the book. And now we can here have books and provide it with our book. again, this can fail. The initializer can fail, so we use try xcc unwrap. And we run the tests again to make sure that we didn't break anything. And to make sure that the test still uses our provided data, we can make it fail by changing the code, the name we put into this book here, and then fix the test again. Perfect. What we also want to have in the book is that we get the let's see. What we also want to have the authors of the book. So we need a new test or a new initializer here. So we want to put in here the authors. And it should be an author. Yeah, we can just put in the name here. So when we look into our API and scroll way up, we see that the authors is an array of persons and they have a name. And for now, we just want to have the name in our authors. So we provide the author, the name property, and we give here exactly the name we get from the API. So let's copy that from here, Shakespeare William. But the compiler isn't happy because we don't have any authors here. And we also, authors should be an array. So we put this into an array. But the compiler still doesn't like this because it doesn't know what an author is. So let's add this code then. Author. You can use a struct here. It should be codable because we want to fetch it from the API and decode it into a book, into the authors array of a book. And for now, it just has a name. Later on, we will also provide the birth and date of death. But for now, we just want to have the name. And the book should have a list of authors. Now let's see if the test compiles. Okay, the incorrect argument, authors with author. Yeah, that's true. So we need authors here. And now the test should compile again, but we want also to check that we see assert equal, that the first book authors is, and it is an array, so it's important, the order is important. We can use this as an advantage here. So we just provide it with this author here. But to be able to do that, or no, let's do something else, because I don't want to. Yeah, it's okay. To be able to do that, we have to provide to make author equatable. So how does this look like? Because it's a struct, this is very easy. We can just use provide it with the name of the protocol here, and everything works by itself. So we should now be able to, yeah, it compiles now. Now this doesn't compile, we don't have the authors here. Let's search for the authors here. So there are two authors now. The first one is this one, and the second one is this one. Okay, so let's provide this with the authors as well, authors, and now we can put in here author name, and the second author name is author name this person. Okay, reformat, perfect. And now the compiler should be happy again. It's not. What's wrong? Wait. Ah, sure. We need to provide it with a comma to make sure that the compiler knows that this is a parameter in the method. Okay, so now we have this author person, and if we now run the test, it succeeds. Okay, that's strange because we haven't added much code. We just added the author field in the book. So let's make sure that it actually tests something. And it does. So this more or less worked automatically because of how Codable works. We just had to provide the authors in the book and make it codable. And when we provide this book object in our session protocol mock, and the session protocol mock automatically creates data using a JSON encoder out of it. So this automatically works without us doing any difficult work. Okay, let's improve that even more, because as we have seen here, we can compare the authors directly. Wouldn't it be nice if we could do something like this for the book as well, like xcc assert equal first book, which is a bad name. We should change that. We do that in a moment. So first book, and we expect it to be book. So the book here we provide to the protocol mock should be the same book in the array we get from the API. So we can do this even better, but first of all, let's make this compile again. And if we have this, if this works, we don't need those two assertions anymore because this does all at once. And the compiler tells us it's not equatable. Book is not equatable. Fortunately, book is a struct. To make this equatable, as all the properties are equatable, we just have to provide it with the protocol name and wait for the compiler. And if we now compile this, the test succeeded, so this works. Now let's see that we didn't introduce an error that the test always passes. So I just remove a character from Shakespeare, and the test still succeeds. So this is not a good sign. Something is clearly wrong here. I'm not sure what's going on here, but this is a good thing to see here, because when we change what we pass into the code and the test still succeeds, then there's an error. So we have to find this error, and we create a breakpoint here to figure out what's going on. And to figure out what's going on, we just look at this code we get here. And the first thing we do is to print the first book. Okay, and now we print the oh, my bad. I realized what the problem is. The problem is we test this book here, and it's the same as we get from here. So if we change the author name here, this is also changed in the book we get here. So we can't figure out now if this test still works. We can only do that when we change how this book is created, when we fetch it. So with this change, we made our test easier to read, but it's more difficult to figure out if it really works. So what we can do here is we can provide an expected book, and also something like that, and then we can compare our first book we got from the API with the expected book. So let's see what we get here. Test still works, and now we remove the E from Shakespeare, and now it fails. So now we show that our test actually works, because it can fail. When a test can't fail, we know it doesn't work. It has no value. When a test always is green, you don't need it. Okay, let's keep it that way, that we have an expected book and a book we get from the API or provide to the API using the URL protocol mock. But I don't like how this looks, it's too complicated. We have books here, we have the first book here, we don't need that. We can just use, I rename the books to fetched books. And we don't need the first book. We can use the fetched books, which is an array, and compare it with an array of the expected array from what we expect from the API. And we expect that there's one book in it, the book we just put into the URL session protocol mock, and it should be essentially exactly an array of one book both times. We expect an array of one books from the API because we provided it with one book, and this is what we use here as an expected value, so an array of one book, and this also works. So let's use this as well down here. This is fetched books. Don't need the first book here, and we can use here fetched books, and this is then we need an expected book here. Expected book. So something is strange with this. Maybe it's because of the size of the font. So now it looks okay. Let's see if it works. First of all, let's make it fail. This fails. And as we can see here, the author name isn't the same. Here the dot is missing. And if we run this test, all the tests again, we now have easier to read tests. They don't look easy to read. And the reason why this is the case is because we have used real book names, and this is not a good idea in tests, because then we don't know if you're really working on test data or on real data, and this is often useful to know when you work with tests. And what we also don't need anymore, because both tests do the exact same thing, they provide the URL session protocol with an array of books to be returned. We don't need both tests anymore. We needed the second test because we just returned one book, one hard-coded book, but this is not the case anymore. So the second test doesn't do anything else here. This is just doing the same thing. So we don't need it anymore. We can remove it. Don't be afraid to remove tests if you don't need them anymore, if they have provided their value. And what we also want to do here, we want to use dummy data, not real book data, to make sure when we see in the printout that this is dummy data from the test and not from the real API, to help us later on when we have to debug our test code or our real code. So this is why I use here dummy book, and the author is dummy author. And the same here, dummy book, dummy author. And now run it again. Everything still works. Let's see if we still have a test that, oh, we have an Xcode crash. So let's run this test again. It's only one test. Run this test again. We don't care. Just run our test, please. Yeah, it fails, and it fails because the name is wrong. So if we use the right name here, it should succeed again. So great. What we have done in this session, in this video, is we created a URL session protocol and used that to replace the session we use when fetching data in our test. So in our test, we create a URL session protocol mock and provide it with the data we want to use in our test. So we want to provide to our API client data we control. We don't want to have it from the server. We want to control in our test the data we put into our API client. And this is done with this URL session protocol mock. We create an object that is transferred into a data object, and this is returned when the API client calls in the book method, calls the session protocol mock. And this way we can test the code that we wrote here in the API client. So if this code, so what we test at the moment is this code here. We don't test that this is the real URL we are using. That's the correct URL. We will do that in the next session. But for now, we test that the data provided by the URL session is transferred into a book array. And this is what we tested here. This tests the API. This tests that our API client calls to the web server to get the books and use this return data to create an array of books. This is a great value for our testing suite, our test suite. So thank you for watching. I hope you learned something in this session, and I hope to see you next time. Bye.